and welcome to Modern Infrastructure here at PulumiTV. My name is David Flanagan, though you may know me from across the internet as Raw Code. Today, I want to follow up from my awesome colleague, Laura, who just published an amazing quick bite on graphs. Graphs are such an important part of working with Pulumi that I thought we should take a look in a bit more detail with code. Before we get into the code, I want to show you how to debug or understand your Pulumi resource graph. Pulumi ships with a stack graph command. This command writes a graph, or at least graph notation, to a file. This notation is called graphviz or dot. This can be viewed as an image with a variety of tools from websites, desktop viewers, or even just in VS Code. It's a pretty well-supported format for graph images. So let's take a look at a simple graph of some resources when we have no dependencies within our stack. So let's start by creating a couple of resources. The first thing I'm going to do is import Pulumi star as random from Pulumi random. This will just allow us to create a few resources, such as a random string, which can equal to random string. We'll just call this first. We'll open up the options and we'll see that we need new. Cool, and we can set the length. So now we have our first resource. Now let's create our second resource, and we'll make this one a random integer. We can do new random integer. We'll call it second, which takes some options. So we'll say min2, max 64, and it takes a seed, which can be just hello. And we have a Pulumi program with two resources and no dependencies. Now we can go to our terminal and run Pulumi up. And it says we're going to create a stack and two resources. Now I mentioned at the start that there is a Pulumi stack graph command, which will allow us to output dot notation to generate the graph to be able to inspect it or visualize it. So we can just output that. I can run cat to pb copy, which copies it to my buffer. And there are a whole bunch of ways to visualize this, but I'm just going to use SketchViz. And what SketchViz allows us to do is to see that we have our graph here, and the two resources that we're creating are actually depending on the stack existing. So we have our Pulumi stack, random integer, and our random string. And there's nothing particularly special about dot notation either. We can open this file inside of VS Code, and we'll see that we have strict digraph. This is a directed graph. Resource 0 is our random integer. We can specify that it requires a resource 1. Resource 1 is just our stack. We then have resource 2, which is our random string, which also has a dependency on our stack. And then the last thing we have here is just a provider, which doesn't really have any dependencies. So it's really easy to work with the dot notation syntax. In fact, you can use this for many, many things beyond Pulumi. Cool. So let's start to manipulate this graph. The first way to do this with Pulumi is via explicit dependencies. And by that, I mean using the depends on resource option. We can take complete control over the graph and the order in which resources are provisioned by ensuring that we explicitly set the dependencies via depends on all our resources. So let's check that out. So let's add our first explicit dependency. Now let's just quickly recap on how resource creation works. We call new on some thing, right? Random string and random integer. The first thing we pass to this function is the name of the resource, followed by a dictionary or object, which is the resource arguments. the information that we need to be able to successfully construct the resource. But all resources have a third option, which is the resource options. You can actually configure the way that this resource interacts with the broader Pulumi program. We can add aliases if we need more than one name for a resource, custom timeouts. We can do lifecycle hooks with delete before replace. We can tell it to ignore changes. We can set a parent, but what's important for today is depends on. And this depends on can take an array of resources that are a dependency that must be created before this resource. And just to make our graph look a little bit more interesting, we'll create one more resource. So let's have a random password equals new random password. We'll call this third, and the length can be 32. And we'll set a dependency on here of a random integer. Now we can come and run Pulumi up once more. We have one resource to create, and then we'll generate our stack graph again. We can jump back to this web interface, copy all this, drop in our new graph, and we can see it's starting to take a bit more shape because we have our provider over here all on its own. There are no dependencies there. We have our graph right at the bottom, our stack right at the bottom. We can see the dependencies follow through. We have our random string, our random integer, and our random password. And we can see that our random password depends on our random integer, and our random integer depends on our random string. So you can use explicit depends on key as a resource option on all resources to enforce the order of creation. Explicit dependencies work just fine, but it can become a little bit verbose, especially if we have other ways to infer the dependency graph. Fortunately, there is. Due to Pulumi's input-output system, Pulumi can actually work out when an output from one resource is being consumed or used by another. When we ask Pulumi to get the result of an output and pass it to another resource, Pulumi automatically builds up the dependency graph for us. So let's take a look at that. Okay, let's remove all our explicit dependencies. We can remove it from here. We can remove it from here. And now we're back to a stack that has no dependencies. Now, implicit dependencies are what Pulumi infers to be dependencies. So when we use an output from one resource on another, Pulumi will detect this. So why don't we use our random string as a seed for our random integer? We can say random string dot result. And then instead of setting a hard-coded length on our random password, we'll use our random integer and say result. So now we can no longer create the random password without the random integer existing. And we can no longer create the random integer without the random string existing. And while we're not setting explicit dependencies with depends on, Pulumi's going to work this out for you. To the point where if we come back and run Pulumi up, it'll replace the two resources. It's doing this because the seed changed to a random string and the length is also random, so that also changed. But we can also regenerate our stack graph. We can copy that to our buffer and jump back to SketchFizz. We can drop this in and nothing has really changed. We still have our provider out all on its own. We still have our stack all the way at the bottom. Our random string still gets passed into random integer. Random integer becomes dependent on random string. And our random integer is passed into random password, meaning our random password is dependent on random integer. This graph is actually no different than what it was last time, although slightly different visualization. And this works at the micro and the macro level. It doesn't matter if your stack has 1 resource or 4 resources, or 200 resources or 1,000 resources. The resource graph is always generated and enforced, meaning that your resources are always created in the right order, minimizing race conditions and risks of error. Well, that's it. I hope you found this video useful. Let us know by clicking the like button, leaving a comment, or hey, maybe even subscribing to our channel. Because we want to help you be successful with Pulumi. And we hope that you found this video useful too. See you all next time.